mechanical engineering technology. So hopefully you're here for the mechanical engineering technology or the technician program. The technology is a co-op program. My name is Rick Balden, and my email is at the bottom left there, rbalden@niagaracollege.ca if you have any questions after this session. We do have some faculty joining us. Aaron Shikoski has joined us. Aaron is a full-time faculty in the mechanical engineering technology program, and Sergio Borghese is a full-time faculty as well. So there's 3 of us here who are all full-time. We do have 6 full-time faculty in the program, so I do want to draw your attention to that. That is significant because our offices are basically in the main hallway. You see the little picture down here on the right. This little picture, I'm gonna get my laser pointer going. In this lab, there's a robotics lab, automation lab, and our offices are directly across the hall from there. So you can find us on campus frequently, which is a significant benefit within our program. We are all, not all of us, but some of us are graduates of the program, but we all come to the program with industrial experience. So all of us have many years of industry, working in the field, applying these principles before we came to the program and teach, so we can speak from experience. Sergio and Aaron are going to be on the side answering any of your questions that you have in the chat box. I'm going to go through a presentation here about the program. So I think I'll start now. So what's mechanical engineering technology and technician program? What's it all about? And when I talk about the program with people, there's kind of these 6 large buckets. There's the world of 3D printing and 3D design, where we use what's called Autodesk Inventor software. This software is embedded on your laptop, and you get a lot of experience. We start using that software in first year, and you will use it throughout. So you will become very knowledgeable, experienced with that software, which is a tremendous benefit having it on the laptop. That way, when you take it home, you can work on it. When you're off on co-ops, you can work on it. It's a lot more, it gives you a lot more experience, a lot more knowledge, because you're not having to go into a lab at school to use it. You will bring your laptop to classroom. We'll show you how to do a lot of techniques. I use a lot of tools, how to create weldments, all sorts of frame generators, all sorts of tools that we'll use. So you'll get a lot of time spent on that. Design analysis using mechanical engineering principles. So looking at what is stress and what is strain and what's that all about, and how do we design to select the right size members, the right size bolts. How do we transfer power? What sort of power supply do we need to make this component move? Or if we want to, in the case of a log splitter you do later on, what sort of loads are you going to experience, and how do you size that properly? So how to do all of that design analysis within the world of 3D printing, and we will use the tool. We have an industrial automation component. I'll show you some photos of our labs later on in this presentation, where you can study robotics. We teach you how to program robots. We do CNC programming, PLC programming, other programming technologies, and how all these devices interconnect and talk to each other. It's one thing to learn how to program the individual components, but now you need to make it work in a system, because it's rare that you see one of these machines working all by itself. Usually it's integrated with other things and other components when you're creating a computer integrated manufacturing cell. And I have some photos showing our lab. Overall manufacturing process design and support. We have students who get careers in the field as process engineers. You know, it's not, when you're looking for jobs and you're looking for further opportunities, jobs aren't always described as mechanical engineering technologists or technician. You know, there's various CNC programmers we have students working in. So in the world of machining, in the world of metal forming processes, there's significant industries around here who do sheet metal forming, who do forging. So understanding the basics of all those processes, castings, and how can you play a role in supporting. Again, you're not the operator, but you're the person they call when there's trouble. You're the person who designs the new process. You're the person who helps to solve problems. And my experience, and Sergio and Aaron, our experience is that typically you're the one they call when they don't know what else to do. You know, an operator can run a machine, and then when things aren't working right, who do they call? They call the mechanical engineering technologist technician to help. Hydraulics, you can be in that field, and pneumatics. We have students who graduated and gone into those types of systems. One student who was actually designing for the Cirque du Soleil, who have the hydraulic systems that are underneath the water to move the platforms up and down. to move the dancers and the gymnasts around the facility. He was actually working for them out of their offices in Montreal. Other processes, we talk about lean manufacturing. So there's this whole manufacturing component as well. And then within the world of manufacturing and automation, there's quality. And we have a significant number of students who have co-op jobs and or full-time positions in the world of quality, where they're actually doing analysis of parts, data analysis. And you start off in the very first year studying quality, how to measure small components, to using a CMM, and then actually doing SPC and analyzing the data. And that'll during your entire 3 years, you're going to go through a period where you'll use those quality tools. So those are kind of the 6 big buckets that I would look at our program and say those are kind of the skill sets you get that allow you to get a lot of opportunities out in industry. It really opens up virtually any job. And what we find is out of all of the small manufacturers, 50 employees, maybe up to even 100 employees, what they want is they want technologists, technicians who have broad skill sets. They don't want with a very specific skill set. They want a broad skill set because they're not going to hire a bunch of dedicated engineers. They're going to hire a couple who have broad skills and then utilize their skills throughout the company, throughout the facility. So you need to learn all that. And all of this work you're going to be doing is done significantly on the laptop. And because of that laptop program, when we did go remote this year during the pandemic, we were very quickly able to transition to that because our students already had all the software. When you come into the program, you lease a laptop, and that laptop is yours for the duration. And it has all the software on it, so that every student is using the exact same laptop with the exact same software, which is the same as we're using. So when you have trouble, we can help you. If you have more trouble, then our information technology department at the college can support you. So within that lease, you pay for service. So that laptop really helped us transition. The students had the software already, and we were able to go virtual very quickly without any loss. I'm not going to go through this slide in detail. If you want to find out specifically what our province considered a mechanical engineering technologist or technician to have the abilities to do, and this is how we design our program. This is the Ministry of Colleges and Universities, and they say a mechanical engineering technologist, by the time they graduate, must be able to do all of these. So let's pick one, for example: analyze and solve complex mechanical problems by applying mathematics and formula and fundamentals of mechanical engineering. Pretty broad. And that's why I'm going to try to detail out in the previous slide kind of the more applicable. These are the general items. So this is what we have to deliver to you. That's what we're obligated to deliver. And there are a number of details that support all these. So if you're ever wondering what is mechanical engineering technology and technician all about, this is another area where you go to this Ministry of Colleges and Universities website on the government website, and you can find all these details. And that really applies to any program you're applying to within the college or university system. If it's an accredited program in the province of Ontario, there will be a description of the program on this website, and that way you can use that to find out a little more about it. So a little more information about our program, and there's going to be some pictures coming up. So just bear with me as we go through some of the text here. So our program, there's a technician program that's 2 years, a technology program that actually takes 3 years and 8 months. And the reason for that 3 years and 8 months is you do 2 8-month terms of co-op. Now that co-op is paid. 95% of our students get co-op placements. Basically, you can consider this 100%. The reason it's not 100% is sometimes 1 or 2 students don't choose to participate. We can't force you to do that. You have to participate. But if you participate, over 95 or probably around 99%, even during the pandemic, all of the students who elected to stay, some students weren't comfortable working during the pandemic, so they took that period off, but all of the ones who chose to stay got employment. So that's good. And our employers are, even now, we're going to be 100% placement. So it's very good opportunities for co-op. The co-ops are paid. The average wage right now is $18.45 an hour. The last I saw from our co-op coordinator, which is a decent wage, $18.45. And that's an average. Some are more, some are a little less. And because of that 60 months of work, that's a little over a year, it makes the program take a little longer. But what ends up happening oftentimes, the students in their very last co-op get full-time offers from that employer and or keep working part-time while they're in school. So it does open a lot of opportunities. So it does make the program a little bit longer than 3 years, but you get all this experience. And during that experience, you're networking, making connections out in industry, which is invaluable. The year one is common. So even if you're not sure about which program you want to go into, which of these two programs, the year one is the same. So from September through to April, you take the exact same program, and then you can switch from one into the other. So there's no problem with that. I want to mention safety in all our labs and workspaces. For those of you who have worked out in industry and you know that there are a lot of hazards. We follow industrial safety standards in our labs. I'll show you some photos of those. Safety glasses are required in all of our labs. And we do strictly enforce that, which is a great habit to be in when you go to industry. We have a lot of quality measurement tools, data analysis that you do. I mentioned the 3D modeling already. In the final design project, I'll show a picture of that in a minute. It includes 3D design, modeling, and a complete manufacturing spec of a device that you're going to make. And I'll show you in a second here. Our equipment is all industry grade. So we don't have school grade or even lab grade equipment. Ours is industry. Our CNC machines, our robots, our PLCs, our vision system, all of that equipment that you're going to interact with is the same equipment if you go in industry. Even our CNC machines, you can buy these. They're $35,000, $40,000 machines that could be running in a shop. And if it's not this machine running in a shop, it's one very similar that's controlled exactly the same way. So really, it doesn't matter. Their final manufacturing or automation project, you will create a fully automatic computer integrated manufacturing cell function. And again, I have photos of that. And I do mention the laptop program again, which I've already talked about. I think I mentioned that it was a lease so that if any damage occurs, we have people on site who will repair it. And the beauty of that is even if you have issues and they can't repair it, they do have loaners available. So you go in there, they can't fix it, they need it for a few days. Here's a loaner. In your first year, we teach you how to back up all of your stuff so that it's always existing in the cloud somewhere, so that if you have to switch computers, you haven't lost any of your information because it's all backed up, provided you've done that properly, of course, and we'll teach you how to do that. So that gets covered. In fact, Sergio and Aaron are two of the people who do teach you how to do that properly, how to actually use your computer. Because although students come to us with a lot of knowledge of computers, maybe some of the industrial stuff, file management systems, protocols, they're not as familiar with as they are with the other soft computer components. So we do go through all of that. Okay, so my page down button works great now. 3D design. Here's an example of your final culminating project. This is a log splitter. So this is a log splitter. Here's a design on the computer, and then here's a colorized version that a student made. And you can see, so this component is a trailerable log splitter. And so the students actually in their last year designed this to meet a certain specification. And when I say design, I mean they were given a spec, and then they have to go out and find all the components. They have to size the beam. They have to size the hydraulic power supply, install the directional control valves, show the hydraulic circuit. So this is the design of the hydraulic circuit by the students. The power supply, the directional control valve, the cylinder, specify which one you're going to buy, go out to the vendor's website, pull in the model, use their actual model on this machine, and then do analysis. So down here in the bottom left, you're seeing what's called a finite element analysis. How do you take the model? So this anvil and this ram are modeled here. There's the anvil, and there's the ram, and there's a point load. And so as we crush or split the log, there's going to be stresses put on this member. What are the stresses? What are the values? And you can see the students did this analysis, and you can see 4/12/2020. I never noticed that before. 5:35 a.m. Interesting. Student must have had a late night there. But they did post within their design package, which they create the manufacturing prints. This is about a 50-page document they create. And we don't just leave it to you. You have a whole course in this in your final year, and the professor who teaches that, which has typically been Neil Walker, one of our full-time professors who's spent a lot of time in the world of design, He takes you through that step by step from week one, creating your engineering logbook, and then every week looking at progress so that you're not just left on your own to do this. He actually guides you through it step by step. This is what you should be doing at this point. This is how it's done. This is how it's documented. Here's how references are made. Here's how all the links are made in software. So you do get led through that whole process. You're not just left on your own to create this. And he does that in class. So it's not, again, not up to you to invent it. We'll show you methods. And these are methods that are accepted in industry. Now, not every industry will do it exactly the same. You'll see that different industries follow slightly different standards, but they all follow, everybody in the world of design follows pretty much the same sequence of steps to get to the final design. And how do you design it for manufacturability? Because not only it's easy to design something on the computer sometimes that can't be manufactured. So we also look at, for example, this little weld down here that you're seeing. Oh, I seem to have lost my little red dot. It's not following me. There it is. There's a little weld down here on this brace. You'll actually analyze the weld. How big a weld do you need? How do you, where should the weld be located? Should it be all the way around? Should it be just on the sides? So this log splitter, portable log splitter, met the spec. And this is, again, an example of work. And the beauty is this package that you make with all the manufacturing prints, you can bring to interviews and show and say, here's my sample. Here's what I'm capable of. And that does help you get jobs. Employers want to see that now when you graduate. They want to know that you can use the computer. We've had students now go off on interviews where you can say that you know how to use Autodesk. You can say you know how to use Excel. They might actually, I've had students after an interview, one of their tasks is to spend the next hour doing some work on the computer and submitting it to the employer so they can actually see a sample of your work to prove that you at least know how to use what you say you can do. So this concept of having the laptop, practicing and doing all these activities over and over again on your own throughout the 3 years and building up your skill set is tremendously important. Again, specifically interviewers have asked that of our students within the interview or post-interview. So you do need to be able to demonstrate what you can do. Here's some more 3D, some more design, lawn roller here. And so you're seeing the 3D virtual model here. You're seeing the complete, manufacturing print of the actual, I call it the barrel or the cylinder. And you see the list of materials up here, parts list required to manufacture this. Here's the individual components, and there'd be detailed drawings of all these components or detailed drawings or actually purchased components and a fabrication drawing. So how do you put it all together? What sort of tolerances are required to manufacture this? Over here on the right, you're seeing an animation. So within the world of 3D, when you create a model, you can animate it, do constraints. You can see here a little gear train, a little power train being animated there. Do all that in the world of 3D. To support that course, there's a final year course where you've learned how to actually do the analysis. For example, here on the right, there's a power transmission within a gear train. And you can see how is the power transmitted, what sort of forces are left on this gear system. Why is that important? Well, somebody needs to decide what size shaft goes in the center of the gear. What size bearings do you need? What sort of housing do you need? Which direction are the forces so that you can specify this roller bearing down here? Does it need to be a tapered roller bearing? What type of roller bearing does it need? Can you use a needle bearing? Can you use a bronze bushing? Bronze bushings take up a lot less room, but they are not as smooth. They're not as efficient as roller bearings. Roller bearings are much more efficient, but they take up a lot more room packaging and they add complexity and cost. Can you just go with a nylon Delrin type bearing? How do you just make all those decisions? You learn that in machine design. And what's interesting to note, and this is a little detail I caught as I was looking through this presentation. This little formula right here, WH, this is all related to the fundamentals of first year physics. So in first year, if you've taken physics in high school, you learn that power, in my course I teach in first year, power equals torque times omega. Omega is your rotational speed. So the power in a rotating system is equal to torque times the rotational speed. Well, that basic formula is used in first year physics, and we learned some things about it. And then what I tell the students is really mechanical engineering is about taking those basic concepts, power equals torque times omega, and applying them to specific applications. You can see that now torque is actually force times distance. And so you can see here where we have power, and using the power and using the size of the gear, we can actually figure out what the transmitted load is. And then we can take those two load components, we can actually convert it into a force. So really what the design side of mechanical engineering and this design analysis is really taking all those fundamental concepts from physics, from math, from thermodynamics, and then applying them to certain applications. So that's in that design world. So that's kind of our whole design and analysis world. Here's some pictures of our lab equipment. This is a picture. We have 4 of these labs. So this is a TORMACH 15L, a CNC lathe with a tool changer. Now this machine here is I had the specs here on it. This is a 3 horsepower machine. This is a machine that you could find in industry. If you were running a machine shop, you could go buy TORMACH. Now, this is not an educational level machine. This is an industrial machine. A 3,500 RPM spindle, 1.5 inch diameter. It's a 2,000 pound machine and 3 horsepower. So this is an industrial machine that you would use in multiple years. You'll manually program it. You'll use MasterCam, which is software that generates the program automatically, and you'll operate the machine. As you can see here, operate the machine, do physical tool changes. So you will actually get experience cutting chips with an industry grade machine, and you will be responsible for your own safety, wearing safety glasses, following all the safe protocols, and then cutting apart and demonstrating that you have the ability to cut apart on a CNC lathe. We also have CNC mills. We have 4. Again, TORMACH is the manufacturer we happen to link up with. PCNC 440 mill. This mill has an automatic tool changer here, and you can see various tools that you could have experience with. The machine is a 10,000 RPM spindle, 600 pound machine. And again, you will operate the machine. You will physically change tools on it, use the tool changers. Up here in the top left, you can see the interface, human machine interface with XYZ, parading the program, CNC program up here in the top left, and then the tool path basically shown in this pictorial. So you will interface with these latest state-of-the-art machines. These machines are just a couple years old. We had the opportunity to upgrade our lab, and so you'll be working with machines that are virtually brand new. In that same lab, we have robots. These are ABB, IRB industrial robots, articulating robots. These are the same robots you would see in industry. Again, not teaching robots. We've adapted them to a teaching world, but the robot itself with the controller, with this cage on the outside, with light curtains from a safety perspective, meets all of the requirements for an industrial Z standard for installation. So you can see what it looks like installed in industry, get that experience and how you interact with it, which is significant. Some labs you go into, some schools, you're actually not working in an industrial application. You're learning how to program the robot, which is one thing. But how do you interact with it? How do you teach it? Staying outside the cage or staying in safe zones, and how do you interface? This is one of our professors as well, Wayne Schaefer right here. He has a lot of experience in industrial automation. And as him and I've got 25 years of experience. It's not real hard to make a piece of automation work. I can go out into industry and I got a piece of automation that runs and I can make it work. It's when it acts up, when it's not working right, or when you need to make changes. That's where the trick is. And how do you execute those? Because to execute those, you have to follow safety protocols. So you can see here in the right, we're following safe protocols. One student is in the cage with both hands on a pendant. So the robot then goes into slow speed. This student is outside the cage and they're working together. This student here cannot go inside that cage. Only one person is allowed inside the cage. And once they're inside the cage with that pendant, all control is given over to this person. So we actually teach you not just how to program it, but how to actually interact with it and use it in a safe manner for your safety, for your coworkers' safety. These are dangerous machines. This is an industrial robot. It can move very fast and it has a lot of force. And if it hits you, it's not going to stop. You know, it's being told to go to a certain point. It's going to go no matter what. Here you can see another student teaching, getting close, moving at slow speed. These other students at the back, there's no case, but what you're not seeing is a light curtain outside that keeps them back so they can't get in close. Outside the machine, they can all get together and look at what they're doing. And then this student, once he's ready, can go inside with the pendant, 2 hands on it, and basically operate it safely. So you will learn that. Within our robot cells, we have vision systems. Again, industrial grade, not home versions. This is industrial grade Cognix Insight 7801C with special Insight Explorer software. Again, this software resides on your laptop. You will connect your laptop up to this vision system. The vision system can check parts. It can decide what part's good, what's bad, and then how does it talk to the robot? Again, it's one thing to learn how to program the actual vision system itself, but then how does it communicate to the robot, the PLC, to decide what's good and what's bad? And where we teach that is when we go and create a computer integrated manufacturing cell. So here you're seeing a conveyor system that's going to move pallets around. This conveyor system, I spent time at General Motors, St. Catharines engine assembly plant, and this palletization system on this conveyor is exactly the same as you would see in any automotive facility. Mind you, ours is scaled down. Theirs is big enough to carry an engine. Ours is big enough to carry small little 3-inch, 4-inch blocks. But the controls are the same. How does a robot pick up from this conveyor system, place a part inside of a machine? How does it take the part out? Sounds simple. You and I can do it with our fingers easy. But designing the robot grippers so that we get that part properly located. And then how does this gripper, whatever's on this machine, the fixture, grab it from the gripper, and how do they interact? You and I can hold the part loose and let it float a little bit and comply. A robot's a lot stiffer. So how do you do that compliance? How do you interface, not just electrically, but also mechanically between these components? And we'll teach you some different techniques and have you thinking about some of that. You can see the students down here in the bottom right looking at the robot simulation, because within the robot software, not only do we teach you how to program it point to point, but we actually have simulation software. So you can test your program, test what you're doing offline, and then download it into the system and see if it works. Here you're seeing students working on the PLC. So this little, what's called a programmable logic controller. And then this is our human machine interface, HMI. This is controlling the integrated manufacturing cell. And so the students have to download programs into the PLC. You have to program the HMI. Somebody has to program the robot. Somebody has to program the CNC machine. All of these devices you need to be able to talk to through your computer. And we teach you all of that. And then we build it up to a culminating project where you make this system function. So that's sort of a world of industrial automation that you will get exposed to as well. So you're not just becoming a CNC machinist or just a robot programmer. You learn how all of these things integrate. And so not only do you have this manufacturing background and automation, but you also have the 3D product design background. So you can go into jobs in either field. From a quality perspective, CMM, coordinate measuring machine. This is a latest state-of-the-art CMM that you can use to measure parts. You will spend time learning DEMIS, PC DEMIS, and software to program this in our quality courses. A few other items we have is 3D printing. We do have some industrial level 3D printers. We also have some desktop 3D printers you can get exposure to. So not only in the world of design, but also 3D printing. And in fact, you will be 3D printing in your first year. So within your first year, you will actually be 3D printing, creating a 3D model and printing it out on our printer. This is another model of a stamping press, a forming press. And this was done by a group of students. And this is a project that sometimes they work on where they have to actually bring different components together from different groups and learn how they fit together. And how do you work as a team to create a model so that all of your components fit and work together and function. Hydraulics, pneumatics, I mentioned. We do have industrial mobile hydraulic benches. We have 6 of these benches. You work in pairs. So this particular hydraulics lab, for example, you come into the lab in a group of 12. So we have very small classes with 6 full-time faculty. So whoever teaches this gets to know you by name. Within the classroom, you spend about a couple hours a week here, half an hour a lesson, on the board at your desk, and then you slide over. The desks are over on the left side of the lab. They're not shown here. And then on the right side are all these benches. And now you'll either A, hook up a circuit, or B, work with an existing circuit and troubleshoot it. And you'll learn how to read these prints and how to design your own circuit and how components work. You know, if a hydraulic cylinder is mounted horizontally or vertically, it behaves different. You know, gravity affects a vertical cylinder. How do you compensate for that? What do you need to do? So you'll spend time on these benches working in both hydraulics and pneumatics. That concludes the pictures from our labs. Now a little bit more experiential learning opportunities. I know a lot of you out there want to get experience. The co-op. Here's a listing, a short listing of some of our employers, some of our most recent employers. Maybe there's some companies here you know of, but you'll see if you look further, deeper into this, 85% of these employers are in the Niagara region. So for our co-op perspective, between 80 and 90% of our placements are in the Niagara region. We also have students who've been placed elsewhere. We've had students out in Ottawa. We've had students in New Brunswick. We've had students. We had one student who on his own found a co-op in Brazil because he was not a jiu-jitsu. He was interested in mixed martial arts. He found a co-op in Brazil, and he went down there, did his co-op, studied mixed martial arts, came back. He finished the program. He's employed now in Montreal, doing very well. But you can see large companies, small companies, lots of opportunities for you. What type of jobs? Well, here's a couple of students that are currently off on co-op. I spoke with them. Dowd worked his first co-op at TIRCON, which is up in Grimsby Way somewhere. Fabricator. That was his job, generating work instructions, looking at packing and solutions, doing quality analysis. Now he's working in Welland at Valbruna ASW. Doing various projects, an ingot dumper, grinding table, ladle teaming card, not necessarily doing the entire design, but doing bits and pieces of it, working through engineering and getting more experience. So these are his two co-ops. This is his current. Olivia Napolitano, currently, her first co-op was with the St. Lawrence Seaway, mechanical designer. She spent time going out into the locks because this was during the winter when they drained them. And they were actually trying to develop drawings of as built. Those locks were built many, many years ago. And so they had old drawings, had drawings that weren't right anymore. So part of her job was creating new drawings in the new software, 3D models, converting it all, doing scanner mounts at the locks that scan the boats as they come into the locks, looking at bridge inspections, getting a lot of experience around the locks, which is kind of a unique experience. And her current job is at Post Foods as a maintenance planner. Post Foods is in Niagara Falls, wheat. They're basically making, as far as I know, I think it's cereal there. I'm not totally sure what exactly they make there. She would know a lot more about it than I would. But she's been working on process flow diagrams, looking at cost of maintenance. So there's all sorts of different jobs that are out there in co-op. And I always tell students that the specific job itself isn't important. It's getting that co-op job, getting that first job and getting that experience. Your first goal going through co-op should be, number one, to get the job. And then number two, don't get fired. And how do you not get fired? Well, it's easy. You show up every day. You be reliable. They ask you to do something. Yes, my very first co-op job going back years ago, back in 1984, was with an automotive manufacturer. Part of my job as a co-op was actually to deliver parts. And so they would say to me, Rick, we need this part to get to Ford in Detroit. It needs to get there tonight. And this is like noon. So here's keys to a vehicle, deliver it for us. Yes, sir. That was my co-op for that day. I got paid to do it. I took a drive to Detroit, dropped the part off with some engineers and came back. It was cheaper for them to pay a co-op than to pay a service like UPS or something. It was actually cheaper to use a student. And so they did that back in 84. I don't know what they would be doing now. Now they'd be doing some virtual things and delivery might be a little differently. But you never know what you're going to be asked to do as a co-op student. And the thing is, you just always say yes. It's a good experience. You'll get good knowledge and you meet a lot of employers. Some graduates. So that was current co-ops. This is current graduates. Current graduates, Robert Brown's a recent graduate. He's working as a CNC programmer at Quartzco. Daniela Cortez, this is maybe, I don't know which job this is, but now she's in the sales. So you could also get in sales. Factory Surplus Direct, what they do is they sell automation automation systems robotic systems to industries. And so she's a sales rep on the road. Ben Lawrence. Ben is a graduate of our program, and he's working at a company called Blue Origin. They're owned by Jeff Bezos from Amazon owns Blue Origin. And what they do is they launch rockets into space, right? They're looking into this whole commercial space. He has knowledge. Ben became an expert in 3D printing through the school. And he was actually headhunted, and he moved up to Seattle, Washington. They moved him out there. They brought him out there for interviews, and he became an additive manufacturing engineer there a few years ago, and now he's their manager of all additive manufacturing in Seattle, Washington, Ben, for them, and that's for their aerospace division. He keeps applying to become one of the astronauts who goes into space. He hasn't got that yet, but he's hoping to. So there's another opportunity. Mike Holdreney is an older graduate. So again, someone who graduated 2011, so 10 years ago. He actually worked for me on a little research project. And we looked at lean manufacturing back then, and we still look at it now, but we did a specific project back then. And he really got interested in that whole world of lean manufacturing, continuous improvement. And then Mike got a job at Moyer Diebel as a continuous improvement engineer. He's worked through the ranks, and he is now in Grimsby the director of operations for Moyer Diebel Canada. He's now pursuing his MBA at Brock. And so this is another opportunity through our program. If you want to further your education, we have links with universities where you can go on and get a degree. There's some specific links to what's called a Bachelor of Technology. If you graduate from our technology program with a 75 average, then you can apply and you get advanced standing, and then it's reduced to get that degree. Mike didn't pursue that. Mike's actually stayed with his technology diploma, but what he's now enrolled at Brock University doing his MBA. They basically waived his need for a degree to do an MBA. And because he has experience in operations and he worked his way through the company, he was a manager before he was a director. And now he's in their MBA program without a university degree and studying his master's at business administration. And they're excited to have someone like him there because he has real hands-on practical experience. You know, he's been working in the real world for 10 years. He's not just graduating from a business program and then doing his MBA. And so he gets a lot of insight, and I've spoken with him. He's enjoying it, and the professors and students are enjoying having him around as well.
Just to kind of go back to the Q&A in case others didn't see the questions. So we had a question, it was asked about internships and field placements, and Aaron did provide the reply that the technology program has 16 total months of paid co-op opportunities. As Rick mentioned, it's really important that students understand co-op at the college level is a little different. They are full-time placements. You're working Monday to Friday, usually around 35, 40 hours a week. As Rick indicated, you're making, $18.45 an hour. It's a good wage. It's definitely above minimum wage. So from that perspective, that's one of the things that Niagara does really well, and they've really developed that program to make sure that there are lots of good student opportunities. That's kind of it.
I can expand on that one, Kyle, a little bit. As far as the co-op program goes, what happens is in your second year, when you come back in September, actually in your first year, we have students right now who are in the co-op. And what they're doing right now in first year, this is the second term, the winter term of first year, they're now doing interview sessions, resume building, cover letter building. What you do is we actually take you through courses, additional courses, where you might spend half an hour to an hour with two ladies who run our co-op department who are fantastic. And they actually teach you how to make a cover letter. You go off and make a cover letter, you submit it to them, they proofread it, they give you pointers, they say, maybe you should change it to this, they recommend formats. Same thing with a resume, you create a resume. The same thing with interviews. They actually do virtual interviews so that you're getting that experience and you get to record your interview, you can watch it, and they can help you develop your interview skills. Their job is, they're not gonna find the job for you, but their job is to get the jobs posted, and their job is to help you find the job. And because we're a smaller college, they get to know you one-to-one. They know every one of their co-op students' names, where they're working, what jobs they've applied to, and they get very involved. So at the end of your first year, you're ready to apply for jobs. You come back in the fall in September, and on Labor Day, when you come back, jobs are posted and you start applying. And then you go for interviews. And once you get a job, you tell them, and then you're removed from the list. And they keep track of that. And they're actually, their job, and they're tracked at how many students are getting placed. So they're, all of our jobs are to help you. So we want to help you. And so when you get that, we help you to get the job. Now you have to create the resume. You have to do the interview. It's up to you to sell yourself, but we'll help you with that. And then once you get that job, you're getting paid. And it's a full-time job for 4 to 8 months. Sometimes it's a 4-month at one job, 4-month at another. Sometimes it's 8 continuous months. What we find is most employers like the 8-month because they get a person in for 1 to 2 weeks that they train them. And now they have a productive employee for 8 months. You're not just there for 4 months. So there's a huge benefit to that 8-month duration, and a huge benefit to the tools that they help you to help you get jobs. And by the time you go for your second co-op, you've already been through a whole bunch of interviews and you're much more comfortable. That first co-op interview can be stressful. You're not sure because these are industry questions, not if you're, you could be working in retail, you could be working fast food restaurant somewhere. Maybe your interview wasn't that intense. These ones are a little more intense. And so the first ones are challenging, and then you become comfortable. So we want to help you get through all that. Sorry, Kyle, just wanted to.
No, that's excellent. I really appreciate your
bit.
expansion on that. That's great. So again, it doesn't look like we've had any questions pop up, but please keep in touch. Thank you so much for your time today. We really do appreciate you being here. I want to personally thank Rick, Aaron, and Sergio. We'll stick around for the next little bit just to make sure if any more questions come in. Otherwise, thanks for joining today, and hopefully you found out more about our mechanical programs, and especially that focus on co-op. Lots of good reasons as to why we think you should pick NC.
Take care, everyone. Hope to see you in the fall.